In lesson 8.1, we're going to start looking at relations and functions. In the first example, we want to identify the domain and range of the relation. So when we look at ordered pairs, okay, we're going to start looking at things that have both an x coordinate and a y coordinate. Okay, two things. This is going to relate back to our constant of proportionality when we looked at the ratio of y to x. And now we're looking at these variables, and we're going to start writing some linear equations and looking at these rules, right? So if you have a rule that you can apply to a number, that whatever the input is, remember we talk about input in a function machine, you guys probably remember that from years past. You perform this mathematical rule and then out pops a number or your y value. And then you could graph those ordered pairs and then they become a linear or a straight line. So when we look at this, the domain and range, these are just some new vocabulary words for you that basically stand for, so let me put this, domain stands for your input value, right? The range is your output value. And if we had to relate input versus output as far as a function machine goes, do we know which one would be the x-coordinate and which one would be the y-coordinate? Okay, so with our concept of input and output, then it makes it a little clearer to see that if you're putting, and I'll do this little illustration over here. That this could be our x value, and this would be our y value. So when you're asked to list the domain and range, for the domain, you want to list all the values of x from the set of ordered pairs that you're given. And then the range becomes their outputs. Okay. Now when I get to B, okay, this is a relation. We didn't say this was a function. This is just a relation. This is a set of ordered pairs. I can see that I have -1 listed twice. It's no need to list a number twice. So if you ever see it listed more than once, you can put them in order numerically, but you don't have to. Oh, I just said that. There's no need to list a number twice, and I did. Because 4 is already represented as an output, there's no need to list that 4 twice. So I went ahead and erased it. So 1, 4, and 7 become the range. And then on this next one, when we look at -1, -3, and 6, sometimes they put the domain in numeric value, but you don't have to. Okay, and then our output then becomes, we have a -1, our range, a 0, a 2, and a 4. Okay, these are just relations. It's just a set of ordered pairs. Okay, let's look at example 2. In example 2, we want to represent this relation as indicated. We first want to graph it, and then we want to do a mapping diagram. So the graphing part is easy because it's on the coordinate plane, and remember that we have these ordered pairs are in x, comma, y order. So they'll go left to right first, then up and down before you put down your pencil. So if you start at the origin always and go to a +2, 0, we'll see how well this does on the graph. Okay, so there's a point. The next one is 1, -1. So find where 1, -1 is. Starting at the origin, over to the right 1, down 1. Okay, third one is 2, 2. So go over to the right and up, and it's actually right here, so go up 2. It's not quite on there. This is going to be hard to pinpoint exactly. I just might have to do a thicker point. There we go. There it is. And then we have the origin right in the middle, 0, 0. So maybe I'll make all of these a little thicker. They're easier to see. And then finally, -1 and 1. Now, this obviously does not represent a proportional relationship. It is not a straight line going through the origin, even though the origin is one of the points. So a mapping diagram, what a mapping diagram does is it takes your domain and it kind of puts them in, it could be circles or it could just be a list. But a lot of times you'll see them with these two ovals, and they list all the domains. So you have your domain, and you have your range, and then we list them again. Let's do them least to greatest. So the smallest one I have is a -1, then I have a 0, then I have a 1, and I have a 2, even though I have two 2's. Then for my outputs or ranges, least to greatest, again, not matching them up. So least to greatest, I would have the -1, the 0, the 1, and the 2. So it's the same numbers in each one of these. And now I'm going to draw arrows to from each domain to the corresponding range. So when I have a -1, I match it up to, or I draw an arrow to, the positive one. When I have 0 as my domain, I have 0 for my range. A 1 goes to -1. And then 2 goes to 0 and to 2.